Welcome back for another video. So this video is going to be on lead in and lead out. Okay, so let's just get right into it. So first off, you notice here I have a contour. So we're going to do two different toolpaths. We're going to work on standard contour, and we're also going to work on circle mill. Those are both similar. So circle mill is similar to Helix bore and all those circle contour paths. And obviously contour is, contour. So that's probably where you're going to use your lead in and lead out the most. Between the two of these, you should get a pretty good idea of how to use your lead in and lead out and all of the settings involved with lead in and lead out. All right, so let's jump in. All right, so as you can see right now, I have no lead in, no lead out on at all for this contour. So what I'm going to do is I'm going to go into contour. I'm going to go into our lead out, or lead in, lead out options. We're going to start right here. So enter exit at midpoint on closed contour. Basically what this is going to do, if I unclick this, it is going to enter where my start arrow is. So wherever I selected my geometry, that's where it's going to enter. If I turn on that midpoint, enter exit at midpoint in closed contours, it is going to enter at the midpoint. It's going to move it over to the midpoint of that line. Overlap. So overlap, what that is going to do, if I make this 0.5, and I'm going to do a lot of this stuff actually from within the menu. If I just hit this plus button, I can see. You can see there, it's basically just going to add an overlap to the contour, to the lead in, lead out, essentially to the whole contour itself, really. I usually leave this on like 10, but you can make it a little bit bigger. It just depends on what you have room for. I default it to 10 just because if I'm making a smaller contour, I probably don't want it to overlap too much. Okay, let's go to entry here. We'll go to entry exit. We'll start with just entry. So if I turn on my entry, we're going to leave this on tangent for now. Okay, so we do have some options here. So I'm going to leave this on tangent. Length. Length is the length of the line before the arc in my tangent. So what I'm going to do is going to make this 0. I'm going to have no sweep on my arc. If this has a radius, it doesn't matter because essentially I have no sweep, so it doesn't make a difference. So if I go ahead and hit plus, you can see nothing really happens there because it's going to make the lead-in line tangent with my profile. So it's going to be in line with it. So you're not going to see anything. So the only way to get a straight lead in is you have to put it on perpendicular. And if I hit plus, that line right there, that lead in line, that is 50 thousandths. If I make that 0.5 and update it, now it's a 1/2 inch. So that's essentially what that line does. Now, if I come back and I go back to my tangent and let's say I add an arc here and I change my sweep to 90, and I go ahead and hit the plus, that line leading up to that arc is going to be a 1/2 inch long. So if you don't have this, if you have this at 0 and you start like that and you're activating cutter comp, in other words, if you have this set to wear or control, it's going to alarm out on you because it's going to put your G41 or your G42 on a G2 or G3 line. It's going to be a problem, especially particularly if you're using a Haas. If you're not using a Haas, some controls can activate, some controls can't. So it really depends on what kind of machine you're using. But in a Haas, this is going to be a problem. So you have to have a straight line lead in here. So it doesn't matter what you make this, as long as it's like 0.1, it has to be essentially 0.01 or something like that. We have to have some sort of line there where it can lead in, some straight line that it can actually lead in. Now, keep in mind, this is showing the center of the cutter, right? Our toolpath lines always show the center of the cutter. So the rule of cutter comp generally is that you have to go at least the radius of your cutter. But since this is showing the center line of the cutter, that's fine. Any length line essentially will work in this case. You just need something. You need a G1 there where it can actually lead into it to create that, that arc. Okay, so next, let's take a look at the ramp height up here. So I'm actually going to make this 50 thousandths just so it's a little longer and you can actually see it. I'm going to make it 0.25. I just want it to be, that's too long. 0.1. There we go, that's better. Okay, I'm going to make this 0.1 as well, just so for continuity there. Okay, so what I'm going to do is look at my ramp height. Now this is going to ramp in. So if I put 0.1 in here and I update this, that straight line, that's a 0.1 ramp. So right now that's ramping down at 45 degrees because it's 0.1 this way and 0.1 that way, which is a 45, 45, 90 triangle. If I make this 0.02 and hit the plus button, you can see now it's ramping down in. I don't use this very often, but there may be some reasons why you may need this. But point is, that's what it does. So I usually have to set to 0. Usually I'm starting off the material and I'm coming down and into the material. I'm leading into the material. So generally I don't need to ramp in. But if you are coming down, plunging into material, you obviously don't want to just plunge down in and then lead in. You probably want to ramp in. So that's how you would do this. Arc. Obviously, I kind of already went over this without actually talking about it, but essentially it's just the radius of this arc. Right now I've set to 0.1, 0.05, hit plus, makes that arc smaller. You can also set these, by the way, as percentages of your tool. So this is basically a percentage of the tool. So I'm using a 1/2 inch end mill here. So if I used 50%, you can see it automatically changes to 1/4 inch. So now I got this huge arc. Again, I usually leave this at like 10% of my cutter. So I'll generally leave that at 10%. Oops, I accidentally hit that button there. Okay, so that's your arc. The sweep. The sweep essentially is how far that arc, how many degrees that arc is. If I change this to 45 and I hit plus, now you can see that I only got a 45 degree arc. I use this sometimes. Sometimes if I'm in a tight, maybe like a narrow slot where I'm leading in to finish an edge, a lot of times I'll do that so that way I don't have it coming in from as far out and I'm not gouging the other side of the slot. So that's a way you can manipulate your lead and lead out to get it into a narrower spot. Helix height. So helix height, this is the ramp essentially that will be on the arc. So if I said this is 0.1 and this is 0.1, and let's plus, okay, so you can see there it's doing 0.1 from here, it's doing 0.1 from here. So this ramp height actually comes from the beginning of this arc height. Now, it's obviously a little extreme, so I'm going to make this like 0.02 and maybe make this 0.05. Actually, I'll make this, yeah, I'll try that out, see how that looks. So you can see how that arcs in there. Really hard to rotate. You can see your arc, though, kind of like helixes down into there. So, again, I don't use that very often. I generally leave that 0. That's 0. And usually if I'm starting off material, that's usually how I'm doing it. Okay. Use entry point. So this really isn't applicable here on a contour. Enter on first depth cut only. Okay, so basically what this will do is if we change our depth cuts to, let's say, 0.02, hit plus, it only does it on the first depth cut. Notice it doesn't have it on all of my depth cuts. So if I go in and I turn that off and hit plus, now it puts lead-ins on all of my depth cuts. So pretty straightforward. Let me turn depth cuts off because that's kind of annoying to look at. And lead in, lead out. Okay, plunge after first move. Okay, so we hit plus on this one. All right, so this is kind of weird. It actually will do that first move, and then it will plunge down to depth, and then arc in. I really don't have... I've never used that. I know what it does, but I've never actually needed to use it. I don't... Maybe there's some weird circumstances where you need to avoid something when you're activating your cut or comp. Maybe in a really, really tight spot, but... aside from that, I don't really see much of a reason to use that. I'm sure there is one. That's probably why they have the setting. I just can't think of one off the top of my head. Feed rate override. This just allows you to override your feed rate on your lead in. So, if you're coming into material and you want to come in a little slower than what your maximum feed rate is, you can just turn this down. This can help with like that overlap mark or that like gap, that, I guess, I don't know what you would call it, but essentially when you get that engagement mark and disengagement mark on the material, obviously spring passes help the most with that, and overlap helps a little bit, but this would also help a little bit as well. So that's a way of kind of getting around that. These buttons here, these just copy your parameters over from direction to direction. So if I hit plus, now they match. I have lead in and lead outs that match, and I have a 10 thousandths overlap. That's that little straight line in between there. Adjust contour. This really doesn't apply here because this is a closed contour. But if you had a partial contour instead of a closed contour, essentially you can adjust the length or shorten the length of your contour. I use this a lot, all the time on basically contours that aren't closed contours. If I want to go a little bit past, let's actually give an example of that. So let me go back into here, go to geometry, exit out, and let's pick a partial chain from there to there, and I'll go ahead and hit extend contour 0.1. Okay, copy that over, check. And there's little things. Let me turn those off. Those are super annoying right now. Okay, so if I go to top view, you can see that my contour is extended a little bit past. So if I made that 0.5, it would probably be a little bit more obvious. So now you can see it's extended quite a bit past. So that's just to make sure that you clean up the whole side edge there. So that's basically all that's used for. That's about it. Oh, you know what? I take that back. We do have a couple other things that I missed. Let's go ahead and go and do a perpendicular. So as I mentioned, perpendicular will just basically make that line perpendicular to whatever your next line is going to be. So if you have an arc, it is going to make that line perpendicular to your arc. So let me change it to both because we're looking at the lead out. That's why it didn't change. So see how it's perpendicular rather than tangent to that arc. So if I made that arc 90, copied it over, now it's starting 90 degrees to that. So usually if you have an arc, you're going to want to be tangent. It doesn't really make sense to lead in like this. There may be some rare circumstances, but it's kind of a goofy way to do it. Usually perpendicular, what you're going to do is you're probably going to have your sweep at 0, and you're just going to lead in perpendicular like that. You could make this at like 1 degree and make your arc like 0.001. Oops. 1. Try that again. Notice it disappears. So there's kind of no tricking this when it comes to, I actually want this at 90, don't I? Oops. So there's no tricking this to kind of like get it to lead in and go at an angle or something like that. Yeah, so it's still going to come in at that 90 degrees there. So you're essentially going to want to go tangent anytime pretty much anytime you have an arc. I keep forgetting I'm looking at the... So you kind of want like almost like an angled lead in. That's how you would do it. You just basically put a small arc in there. But you can't trick the perpendicular into doing that. It's always going to be perpendicular from it. So lastly is the profile ramp. So let me go back to my profile here and reverse that. Check. And go to lead and lead out. We're going to do a profile ramp. Oh, oops. And we're going to do a ramp angle of, let's do 3 degrees. 0.1, we'll make this 10% and 45. Let's take a look at that. Oh. There we go. Okay. So you can see I got a tangent lead in. That's my 0.1. And then there's my arc of 45 degrees, my 50 thousandths. And then it's actually going to ramp down at 3 degrees for the entry. And then, of course, obviously, I have an exit ramp out. If this is a case where I wouldn't want them the same. I wouldn't want an exit ramp. So in this case, I would probably just do a tangent. And I'd probably just roll with that. So I'd probably exit out like that. 50, 45, yeah. So there, it's profile ramping down. In fact, we can actually take a look at this in our back plot. And I don't want this to go flying through. It's a little slower than I thought it was going to be. So it comes down, gets to the bottom. Now it's going to go all the way around. And then it's going to do its exit motion 10 thousandths after. So there's still going to be that 10 thousandths overlap. So it's kind of an example of how that profile ramp would work. Although I will say that this is leading in perpendicular. Not sure why that's leading in perpendicular exactly. Oh, so it'll lead in however whichever one you had selected last. So if I go to tangent, this is kind of an interesting, let me turn these adjust contours off. So if I go to tangent, hit plus, and then I go to profile ramp after tangent and hit plus, now it will be on tangent. If I wanted that to be perpendicular, I would go to perpendicular, hit plus, and then go to profile ramp and hit plus. Now it would be perpendicular. So if you want that lead in to be perpendicular for some reason, that's how you have to do it. Kind of a goofy little trick that I figured out a while back when I was doing this. I don't use this often, but for some reason I was struggling to get that to work, and ended up figuring that out. Profile ramp plus. Okay. So now it looks pretty good. So now if we simulate that, play, now I can see it came in tangent, comes around, and finishes up. All right, so that's all for contour. What we're going to do is move on to our circle mill. All right, so this is one that students have trouble with all the time. Basically, what we have here is we're essentially milling some sort of circle, helix boring. It doesn't matter. Either one, it's kind of the same setting. So as you can see here, we're helixing down. All right, we're not going to be activating cutter compo in the helix. Okay, we're only going to be activating cutter compo on our finish pass. So this is where our finish pass occurs. So this is where we're looking at. And you can see here, it's kind of using this rough, and then it's leading straight in, doing the finish pass, and then this yellow line is retracting out. That's actually our exit. Okay, so in circle mill, what we're going to do is, first things first, we're going to go in and we're going to go to our finishing. We're going to make sure finishing's on, it is, and we're going to go to transitions. All right, so in transitions, we have a couple of different things we can do. High-speed entries, kind of cool. It allows you to easily transition into them. Doesn't really matter too much unless you're taking like multiple finish passes or maybe some spring passes. But we're going to make sure lead in, lead out zone, because we need to enter with a straight line long enough that essentially it's more than the radius of our cutter. So what we're going to do is turn on lead in, lead out, start at center, end at center. And I'm going to hit plus. Oops. Messed something up there. All right, so now I'm going to hit plus, hit the X, I guess, instead. Okay, so now if we look at this path, you can see that we're entering and we're leading out. So we're entering from the center, leading in a straight line, activating cutter comp on that line, and then arcing in. So that is what we want. In this case, that's exactly what's going to give us essentially the code that we need. Also, you can change this. You can change this to like 45 or something like that. It's just going to change how much it arcs. I'm going to do 90, hit plus. Okay. So there we go. That's it. That's all there is to it. You just got to have those on, and you just have to look at your toolpath and make sure that you have that straight line lead in. So if I actually post that code, check. No. Wow, this is going somewhere weird. Let's hit save. Yes. See if we can get this to come up quick and just take a look at where our... So this is our ramp here. It's our helical entry. So this is a roughing. And then right here we got a G1 move. And then it's activating cutter comp on another G1 move and turning on our tool diameter. And then it goes into a G3. So that's what you want to see. That should be just fine. And then G1, G40. So G40, our deactivating of cutter comp, is also on a G1 move. That's what you want to see. Okay. Let me change this real quick to a Helix bore, because this is a little different. And let's come in here and let's just hit plus. And we'll put 0, 0, plus. And we probably need to put a depth, negative 0.25, plus. All right. Now, if we look at this, you can see right here that's starting on an arc. Now this time we are activating cutter comp on our Helix. So with a circle mill, it's just doing a rough. It's just basically doing that by computer, and it's just doing a helix down. It doesn't activate cutter comp on that helix. Here, it's activating cutter comp because it's taking the helix to size. So we need cutter comp activated. The way you get this one to work, notice start at center is already on. Those do need to be clicked. But your entry exit sweep is 180. We need to change that to 90. Hit plus. Now it gives us that lead in line that we need to come in there. If you hit perpendicular entry, it's just going to make an extra line. So it's going to kind of do a bunch of... It's going to do that instead. So it's not really necessary. So we'll just hit plus. Plus. There we go. Check. And now if we post that code and go ahead and hit check. No. Save. Yes. It's going to ask me if I want to load things 18 times. Yes. All right. There's our helix. Well, let's go to the beginning. Okay. So... Oh, I probably didn't have cutter comp on. I clearly did not because I changed the toolpath. Computer, no. Where? Off to the left. Okay, plus check, and let's post that now. My mistake. Great example of why you look at your code. Yes. Okay. And right here, G1, also a G1 line. It's activating cutter comp, and then it's going to G3. So, should have no more cutter comp errors if you follow those instructions. All right, well, hopefully this was helpful for lead in, lead outs. If you have any other questions, check out some other videos or leave some comments.